electron affinity is similar to ionization energy, but kind of backwards. So electron affinity is the energy change when you add one electron to an atom. Going into the valence shell again. Remember, ionization energy was the energy required to take away an electron. Electron affinity is the energy change when you add one electron. And that can either be positive or negative, depending on the atom. But the trend follows the same pattern as ionization energy. That is, the closer you get to this corner right here, the more negative, in this case, the electron affinity is, in general. Here's the table here. It's not a perfect trend. You can see things generally get more negative, but there's bumps and things, so it's not a great trend. But in general, electron affinity increases as you get towards the fluorine corner of the periodic table. And so if you know like for example, for oxygen, the first electron affinity is a negative number. The second electron affinity is actually a positive number. It takes some work to push that electron on there. And because of the extra repulsion that's created when you put it in there. So whenever oxide ions are formed, there has to be some kind of energy released from some other process. For example, the ion sticking to another ion, like making calcium oxide, for example. That lattice energy would compensate for this cost.